Good morning, Mr. Pao Q Nai. My name is Tae Hong Kang. Now I will introduce my group member. Our group is group 14 and my team member have Ho Cheng Long, Lo Fang Yi, and I will Lo Weng Hong. So in our choosing topic is Deadlock, and we create a question and do the solution of this topic is need to understand the system in the situation of safe or unsafe. The deadlock will be occur and the deadlock can be avoided. And the last is the request of addition intenses can be granted or not. So in learning of this topic is our group learning about what the deadlock is. The deadlock is the permanent blocking of process that either compete for system resources or communicate with each other. Meanwhile, a set of block process will hold a resource and waiting to acquire a resource held by another process in the set. So we main focus on the deadlock avoided is because that have involved a decision that met dynamically whether the current resource allocation request will, if greater, potentially lead to deadlock. So in our question, we have the 5 process in a system P1, P2, P3, P4, and P5. And we have the 3 resource type A, B, C. A have the 10 intenses, B have the 9 intenses, C have the 8 intenses. So in this table, we have the allocation table and the max table. And now we need to see the allocation part because we need to find available intenses. So the allocation table is the part of a part of the value that the process will hold. Process will hold the intenses. And the max table is the processes can be hold the maximum intenses in the resources. So we can see the allocation table. We have the 2 intenses in A. So we have the 2 lights draw through the P1. And the 2 have the 0, so no need to draw a light. So the process 3 have the 1, so we need to draw a 1. So the next is the P4. The P4 have the 2, so we need to draw the 2 lights in the P4. And the P5 and is the 1 is have the 1 intenses, so we need to draw a 1. So we can see the available dots is 1, 2, 3, 4. So we can know the intenses of the available. The intenses have the available is 4. So the A is the 4 available intenses. So the next is we need to see the B. Need to check the B at the how many available intenses. So we see the allocation table. Process 1 have the 1 intenses, so we draw a 1 light. Then the P2 have the 1, so we draw a 1 light to the P2. And 3 is nothing to draw, so not to draw a light to the P3. And 4 have the 2, so we draw a 4 2 intenses to P4. And P5 have a 1, so we need to draw 1 light to the P5. So we can see the available dots is 1, 2, 3, 4. So also have the 4 intenses is available. So we can see the available for our solution is the B resource have the available intenses is 4. And the last is the C resources. And we see the allocation table. The first one P1 is not the intenses involved, so no need to draw. And P2 have the 3, so we need to draw a 3 lights. And the P3 have the 0, so no need to draw a light. And the P4 have the 1 light, so need to draw a light to the P4. And the P5 have a two light and a two intenses, so we need to draw a two intenses to the P5. And the last we check the available, and the available dots it have 1 2. So in C we can get the answer is the available intenses of C at 2. So we get a available value for the ABC 442. We need to find the resource need. The resource need is the formula is the need equal to max subtract to the allocation. So we need to based on the table to find the needs resources. So the max we need to see the max and the allocation to to find the needs, and we based on the first the process one, the max A intenses variant is 3, and the allocation table for the P1 A intenses is the intenses value is 2, so the 3 minus 2 is equal 1, and the B variant for the max is the 3, and the allocation part for the P1 is B equal B value is 1, so we take the 3 subtract to the 1 equal to 2, and C intenses is 2 for the max, and allocation value is C equal to 0, so we need to subtract the 2 subtract the 0 is equal to 0, so we can see the answer is the answers for the first one process is 1 to 2. Okay, so next the P2 is A is allocation A is 0, B 1, and a C is a 3, and the max A ABC intenses is 5 7 8. So we do again the formula. 5 subtract the 0 is 5, and the 7 subtract the 1 is 6, and the C intenses value is 8, and subtract to the 3 equal to 5. So we can base on this, we can see the answer is 565. So we get the answer for the next is a 565 intenses. Okay, so the next one, the P3, the allocation is ABC is 100, and the max table for the P3 is 511. So send the formula, the 5 subtract the 1 equal to the 4, and the 1 subtract 0 equal 1, and the C variant is 1 subtract the 0 is equal to a 1, so we get the answer for the next intenser for the ABC is 411. Okay, and the next step for the ABC max we see the max variant is the P4 max variant for the ABC is 442, and the allocation part for the P4 is 221. So the same formula, the max A intenses variant is 4, the allocation variant is 2, the 4 subtract to the 2 equal to 2, and the B 4 subtract to 2 equal to 2, and the C 2 subtract to 1 equal to 1, so we get the answer is 221 for the intenses need. And the last one P5 is the allocation variant is 112 for the ABC, and the max table allocation is 563. So we get the answer for the A is 5 subtract 1 equal to 4, the 6, the B value is 6 minus to the 1 is 5, and the last one, the C intenses value, the 3 minus 2 equal to 1, so we get a answer is 451. So we get a all answer for the process is that here. So this my part is finished, so thank you.
For the safety algorithm, we got to check to determine whether the available is less than or equal to the need. The values for the available are 4, 4, and 2. So in process 1, the need is 1, 2, 2. So I have 4 while the need is 1. That means I have enough. I have 4 while the need is 2. That means I also have enough. I have 2 while the need is 2. That means I also have enough. So the process 1 will be true. And we can actually run it. If the result is true, we need to update the available. Our available is 4, 4, 2 plus 2, 1, 0 from allocation P1. Process 2, the need is 5, 6, 5. I have 6 while the need is 5. That means I have enough. I have 5 while the need is 6. That means I have not enough. I have 2 but the need is 5, which is also not enough. So the process 2 will be false. For process 3, I have 6 and the need is 4. And I have 5 and the need is 1. And I have 2 and the need is 1. All are enough and it is true. So we need to update the available, which is 6, 5, 2 plus 1, 0, 0 from P3, which is 7, 5, 2. For P4, we have 7 and the need is 2. We have 5 and the need is 2. We have 2 and the need is 1. All are enough and they are true. And we also have to update the available, which is 7, 5, 2 plus 2, 2, 1 from P4, which is, and the final answer is 9, 7 and 3. For P5, I have 9 and the need is 4. I have 7 and the need is 5. I have 3 and the need is 1. So it is true. We also need to update the available, which is 9, 7 and 3 plus 1, 1 and 2 equals to 10, 8 and 5. And lastly, P2, which is I have 10 and the need is 5. I have 8 while the need is 6. I have 5 while the need is 5. So, which is enough. So, it is true. And we also have to update the available, which is 10, 8, 5 plus 0, 1, 3 equals to 10, 9, and 8. After completing the calculations, we need to choose all the true processes to form a safe sequence, which is P1, P3, P4, P5, and P2. In conclusion, the system is in a safe state. Therefore, deadlock can be avoided. That's all from me. Thank you.
Good morning, Mr. Bao. My name is Huang Long from Group 14. Today I take part to present the question 3 in this project presentation. Let's look to the question 3. In the question 3, we want to request the additional instances 211 to the P3. Is this can be granted or not? Let's check. In the solution in question 3, in step 1, we want to check the request and the needs for P3. The needs that we have in P3 is 411, and then the request that we want to request is 211. If the needs that's bigger than the 211 that we request, so it can fulfill the condition, so it is a result in true. In the step 2, we also want to check the request for available. The available for P3 is 442, and the request that we want to request is 211. So it can fulfill the condition for 211 that we request, so the result is the true. Later we move to the banker algorithm. In banker algorithm, first we want to calculate the P3 allocation. The P3 allocation is the 211 allocation 211 plus the 211 is a request plus the allocation, so you can get the result in 311. And then we want to calculate the needs. Needs is the maximum 511 minus the allocation 311, so we can get the answer in 200. And third, we want to calculate the P3 available. The available for P3 is 442. And then we want to minus the request, so we can get the answer in 231. After we calculate all this, we want to update our answer, the latest answer to this all the table. For example, the available 231. And then we move to the safety algorithm. Safety algorithm, we want to check the algorithm is safety or not. First, we want to look at the needs and the available. P1's available is 231, but the needs is only 122. But this is 122, so it cannot fulfill the condition because this is a little bit much bigger, so it caused the result in false. And then in the P2, the available is also the same 231, and then the needs is 565, is much bigger than the available that we have, so in the result is false. But in the P3 that available also the 231, but the needs we only need 200, so it can fulfill the condition because it is enough bigger, can fulfill the condition, and then the result is true. When the result is in true, right, we want to update the available. Like at the table now, our available is 231, and then if this is true, right, we want to using 231 plus the 311, the P3311, so we can get the answer in 542. And then we move to the P4. We use the new available is 542. We want to update the latest number, and then we move to the next step. So we carry forward to here. The 542, and then the need state for P4 is 221. So it can fulfill the condition, so it can result in true. And then we also want to update the available one more time, the 542 plus the 221 for P4, so we can get the new available in 763. And then we move to check the safety for P5. The P5, the new available, from here we carry forward to here, so the available is 763, and the next we want to that we have is 451, or it also can fulfill the condition, so the P5 is result in true. If it is true, yes, we need to calculate again the new available. The old available is 763, 1 plus the 112, so can result in x75. And then after this, we want to calculate the P1. The P1 is the new available is x75, and the P1 is 122. It can fulfill the condition, so it result in true. Then we update one more time the available, the x75 plus 210, so we can get the new available in 1085. And then we move to the last step is the P2. P2, the new available is 1085, but the needs that we have is 565, so it can fulfill the condition, so it calls the result in true. If it's true, right, we need to update the number again for available, the 1085 plus 013, so we can get the new available in 1098. After we complete all these calculation, true and false, right, then we need to choose all the true process, and then we want to make a safe sequences according to the true number, right? First is P3 is true, right? P3, P4, P5, P1, and P2. According to here, all the true number accordingly. If all this is compared, right, then we can make a conclusion for this question 3. The request 221 from P1 can be granted because system is in a safe state, therefore deadlock can be avoided. That's all for my presentation for question 3. Thank you.
Hello sir, my name is Lo Fang Yi. Now I will present question 4. If the request 222 from P1 is that can be granted. First step, we want to check the need for P1. Does its request more than its need? If yes, it's false. This 221, this 222, so it's false. And then check the available for P1, 231, also is false. So this question cannot be granted. So that's all is our presentation. Thank you, sir.